Yes, today we are going to start with the 10.1 parametric equations. We know that the equation x square plus y square is equal to 1 is the equation of the unit circle. That is the circle with the center, origin, and radius 1. So this is a rough sketch of that. Clearly, this equation does not represent a function. The reason is it does not pass the vertical line test. So it's not a function. The graph does not pass the vertical line test. X and y may be expressed as a function of another variable t known as a parameter. And x is equal to cos t, y is equal to sin t satisfies the equation x square plus y square is equal to 1 because cos square t plus sin square t is equal to 1. When t is equal to 0, x is cos 0 which is 1 and y is sin 0 that is 0. So the point is 1, 0. So when t is equal to 0, the point is here 1, 0 on the unit circle. As t increases, the point xy moves along the unit circle, along the circumference of the unit circle. When t is equal to pi over 2, the point xy is 0, 1 because cos pi over 2 is 0 and sin pi over 2 is 1. And when t is equal to pi, the point again moves to negative 1, 0 along the curve, the circumference of the circle. Because cos pi is negative 1 and sin pi is 0, when t is equal to 3 pi over 2, the point xy is 0, negative 1. That is because cos 3 pi over 2 is 0 and sin 3 pi over 2 is negative 1. And when t is equal to 2 pi, the point is again back at 1, 0. Cos 2 pi is 1, sin 2 pi is 0. So x is equal to cos t, y is equal to sin t, t varies from 0 to 2 pi is the parametric equation of the unit circle. Similarly, any curve may be parameterized in general. X is equal to ft, a function of t, y is equal to gt, a function of t, t varies between a and b, represents the parametric equation of a curve. That is the general formula. If the parametric equation of a curve is known, then we may draw the curve by preparing a table with the columns t, x, y. So usually you assign values for t, then find the corresponding values of x and y. Then you plot y against x on the xy plane. The graph may be drawn using TI 83 or 83 plus. First step is keep the calculator in the parametric mode. Here it is. So you turn on the calculator, clear. Then here is how you go to the parametric mode. Keep the calculator in the parametric mode. So that is, you click the mode and bring the cursor to the parametric VAR. So enter. Then the second step is enter x and y by pressing y equal to, say y is equal to, clear, cos t, sin t, cos t, y is equal to sin t, and let us set the window from negative 2 to 2. T varies from 0 to 2 pi, 0 to 2 pi then x minimum negative 2, x maximum 2, scale 1, y minimum negative 2, y maximum 2, scale 1, and a graph. It does not look like a perfect circle, so what you have to do is go to zoom z square, number 5. So it represents the unit circle. So this is how you use the calculator to graph a parametric equation. Okay, 10.1 again, sketch the graph. This is the question from the textbook. Sketch the graph and indicate by an arrow the direction in which the curve is traced as t increases. Then second part is eliminate t to find the Cartesian equation. Cartesian equation is an equation containing x and y only. So x is equal to 3t plus 2, y is equal to 2t plus 3, and equations are linear. So if the equations are linear, you need only 2 points to graph it, because 2 points are enough to draw a line. 2 points are enough. T is equal to 0, x is equal to 2, 3 times 0 plus 2, 2, y is 2 times 0 plus 3. So that point is 2, 3. This is the point 2, 3. And then t is equal to 1, x is equal to 3 times 1, that is 3 plus 2, which is 5. Y is equal to 2 times 1, 2 plus 3, that is 5, 5. So I have drawn the line by using those 2 points. And as t increases, the arrow goes up, because this is t is equal to 0 and this is t is equal to 1. And now you have to eliminate the b part. Eliminate the t. So x is 3t plus 2, subtracted 2, you get 3t is equal to x minus 2. Divide both sides by 3, you get t is equal to x minus 2 divided by 3. Y is equal to 2t plus 3, you replace t. T is x minus 2 over 3. So y is equal to 2 times x minus 2 over 3 plus 3, that is distribute 2, that is 2 over 3x minus 4 over 3 plus 3, that is y is equal to 2 over 3x plus 5 over 3. You may use your calculator for that fraction. I know if you are not really good in arithmetic, you can use the calculator. This is negative 4 over 3 plus 3. This is a decimal. Go to math. Fraction is highlighted, enter twice. So 5 over 3. So y is equal to 2 over 3x plus 5 over 3 is the Cartesian form of that equation. Okay, now question number 8. Y is equal to, x is equal to sine t, y is equal to 1 minus cos t. T varies from 0 to 2 pi. Y is equal to 1 minus cos t. First we are going to eliminate the variable to see what the shape is. 1 minus cos t is y. So y minus 1 is equal to negative cos t. Therefore, x squared plus y minus 1 the whole square is equal to sine squared t plus negative cos t the whole square. That is sine squared t plus cos squared t, which is equal to 1. So here is a trick. If sine t and cos t are involved, always isolate sine t and cos t, then square them and add and use the property sine squared t plus cos squared t is equal to 1. So this is the equation x squared plus y minus 1 the whole square is equal to 1. This is a circle with the center 0, 1 and radius 1, because general equation is x minus h the whole square plus y minus k the whole square is equal to r square. So this is x square. It means x minus 0 the whole square plus y minus 1 the whole square is equal to 1 square. This is a circle with the center 0, 1 and radius 1. Question number 10. X is equal to t square, y is equal to t cubed. In this case, I'm going to prepare a table and later we will eliminate. So you prepare a table with the t, x, y and use some negative values, positive values for t, I pick the negative 2 for x first. Negative 2 the whole square is 4. Negative 2 the whole cubed is negative 8. Then next value, negative 1. When t is negative 1, x is negative 1 the whole square, that is 1. Y is negative 1 the whole cube, that is negative 1. When t is equal to 0, x is 0 square, that is 0. Y is 0 cubed. X is 1. Sorry, t is 1. X is 1 square, that's 1. Y is 1 cube, that is 1. When t is equal to 2, x is 2 square, that is 4, and y is 2 cube, that is 8. Now you draw y against x. This is the x-axis, and here is the y-axis. When x is equal to 4, this is 4. Oh, sorry. When x is equal to 4, 4 is here. 1, 2, 3, 4. When x is equal to 4, y is negative 8, and also y is positive 8. And when x is equal to 1, y is 2 or negative 2. Sorry, not. Oh, there is a small mistake here. When x is 1, y is 1. So this point is a little bit below here. That is a problem with the scaling. Please correct it. I don't want to redo it. So that point will be here and here. So it will be more bent. Okay, now we are going to eliminate. Y is equal to 2 cubed means t is equal to y to the 1/3. X is equal to t square. So that implies x is equal to y or y to the power of 1/3 the whole square. That implies x is equal to y to the 2/3. So that is one way to do it. Or the second way is x is equal to t square. So x cubed is t to the 6. Y is equal to t cubed. So y square is t to the 6. That means y square is equal to x cubed. X cubed is equal to y square. That is another way to find the Cartesian equation. Next. X is equal to e to the t. Y is equal to e to the negative t. See, remember, both x and y are positive. So the graph is strictly in the first quadrant. So y is equal to e to the negative t. That is 1 divided by e to the 2t. Y is equal to e to the negative 2t. That is 1 divided by e to the 2t. That is 1 divided by e to the t the whole square. That is 1 divided by x square, because x is equal to e to the t. So the graph is y is equal to 1 over x square, and x is greater than or equal to 0 because of this condition. So that means it is a rectangular hyperbola that lies in the first quadrant. Okay, let us see whether that is right. Okay, so x is equal to e to the t. E to the power of t. Y is equal to e to the power of negative 2t. E to the power of negative 2t. Yes, so that is the equation. Now let us try to draw this one. Y is equal to 1 over x square. So for that you have to change the mode to function. Y is equal to here 1 over x square. Now I'm going to keep that in parentheses. I'll tell you the reason in a minute. 1 over x square. And you know x is positive, so parenthesis x. Now you go to second math. You have greater than or equal to here, that is number 4. greater than or equal to 0. And now you graph it. You get exactly same graph. Okay, so number 16 is a really easy one. X is square root of t plus 1, y is square root of t minus 1. Since there are radicals, both x and y are positives. Therefore, the graph will be in the first quadrant itself. Squaring, you get x square is equal to t plus 1, and that means t is equal to x square minus 1, and y is equal to square root of t minus 1. That is, y is equal to square root of t minus 1. So it is x square minus 1 minus 1. Here also there is a small mistake. T is x square minus 1. So y is square root of x square minus 1 minus 1. That is x square minus 2. So this, please correct that mistake. Y is equal to x square minus 2. T is x square minus 1. So x square minus 1 minus 1. That is x square minus 2. Then x is equal to tan square t, y is equal to secant t. T varies from negative pi over 2 to positive pi over 2. So secant y is secant square. Sorry, y is equal to secant t. We know an identity from trigonometry. Secant square t is 1 plus tan square t. So here secant square t is y square. Y square is equal to 1 plus tan square t is x. Y square is equal to 1 plus x, or x is equal to y square minus 1. And that is a part of the parabola because t varies from negative pi over 2 to pi over 2. Since t varies from x is positive, since t varies from negative pi over 2 to pi over 2, cosine t is 0. Sorry, cosine t is positive in the fourth quadrant. So secant t is again positive. So the graph is strictly in the quadrant 1. Now let us see the flow. When t is equal to negative pi over 2, x is equal to tan square pi over 2, that is infinity. Secant is again infinity. So the graph comes from infinity and it reaches the point 0, 1, that is this point, and again goes back to infinity. So because when t is equal to 0, it comes here. When t is negative infinity, it is at infinity, and it comes to 0, 1, and when as t increases further, it moves back to infinity. Question number 20. X is equal to 2 plus sin t, y is equal to 1 plus 3 cos t, pi over 2 less than or equal to t less than or equal to 2 pi. X is equal to 2 plus sin t implies sin t is equal to x minus 2. Y is equal to 1 plus 3 cos t implies 3 cos t is y minus 1. So cos t is y minus 1 over 3. Sin square t is equal to plus cos square t is equal to 1. So x minus 2 the whole square plus y minus 1 the whole square over 9 is equal to 1. This is an ellipse which is stretched parallel to, the major axis is parallel to the, see, look at it, y-axis, because the denominator of y10 is bigger. So major axis is on x is equal to 2, and now we see t is equal to pi over 2. That's the minimum value of t. X is equal to 1. Where is x? X is 2 plus sine pi over 2. Sine pi over 2 is 1. So it is 2 plus 1, 3. Y is equal to 1 plus 0 because cos pi over 2 is 0. So that point is 3, 1. So that point, it starts from the point 3, 1. It is here, 3, 1. And it is an ellipse. And then when t is equal to pi, x is 2 and y is negative 2. You simply plug in the numbers. And so the point is 2, negative 2, that is this point. And then it reaches to -2. When t is equal to 2 pi, x is 2, y is 4. Just plug in the values 2 pi there. So it reaches the other vertex of the ellipse. So it is not a complete ellipse, it's a part of 3/4 of an ellipse. Number 22, x is equal to sine t, y is equal to cos square t. T varies from -2 pi to 2 pi. X square plus y is sine square t plus cos square t, because x is sine t, x square is sine square t, y is cos square t is 1. So the equation is x square plus y is equal to 1, or y is equal to 1 minus x square. Y is equal to cos square t, that's greater than or equal to 0. So the path is the parabola with the vertex 0, 1 and above the x-axis. So the graph will be like this. Now, this is a parabola. Y is equal to 1 minus x square above the x-axis. So because y is positive. And now you prepare a table to see how it behaves. So this table, -2 pi to 2 pi. So you find the x and y values at these junctions: -2 pi, -3 pi over 2, -pi, -pi over 2, 0, etc., etc. You get it starts from 0, 1 here. Then it goes to 1, 0. That is, it moves come down here. Then it moves along the curve, goes to -1, 0. And again, it goes to 1, 0. And again, it goes to -1, 0. And finally, it reaches 0, 1. So it will be starting at 0, 1 and ending at 0, 1. But there are several variations. I mean, several movements. It goes from 0, 1 to 1, 0, then again back, and again then goes to -1, 0, and go back to 0, 1, and then it moves on. The particle starts at 0, 1, moves to 1, 0 along the parabola. Returns to 0, 1 along the curve, then goes to -1, 0, and return to 1, 0 along the curve. Again, it goes to -1, 0, then back to 1, 0 along the curve. Okay, so that is all about 10.1. I have seen 2 minor mistakes here. You have to fix those mistakes.